For the next few days, we'll be actually talking about factoring. Today, we'll start with GCFs and just your typical trinomials. The first thing we're going to talk about is GCF, which is greatest common factor. And basically, it's the factor that is obviously the greatest that goes into all of the terms. So if I look at this first one, 3 goes into 3 and 9, so that would be part of the GCF. Both terms have at least one x in them, and they also have at least one y in them. So that's the highest that can go into each one. Then basically what I do is I kind of divide each term by that GCF. The 3's cancel out, the x's cancel out. Oh, there's one x, sorry, left. But the y's cancel out. So one x is left when dividing. And when I do to the second term, I get 3, x's cancel out, and I'm left with 1y. Y squared over y is y. And that's taking out the GCF right there. One of the very first rules you should be looking at for every problem when you're factoring is if it has a GCF. That will make the problem much simpler to work with if you can figure that out first. We're going to start with some basic trinomials and how you can quickly factor them. Again, this should be a little bit of a review from last year, from Algebra 1. If I have 3 terms, x squared plus 9x plus 20, basically I'm trying to figure out how I can kind of break it apart into 2 binomials and FOIL it to give me that trinomial. And one way to do that is to think of 2 numbers that multiply to 20 but add to 9. So you can kind of go over here and think of the factors that give you 20. 1, 20, 2, 10, 3 doesn't go in there, 4 goes in there 5 times, and then if I did 5, it would just keep reversing, so I can stop at 4, 5. And then I look at my factor pairs. Can 1 and 20 give me 9? Nope. 2 and 10? Nope. But 4 and 5 can. So I can put 4 here, 5 here. And since x squared is a perfect square because it can break into 2, and x goes here, x goes here. Since it's positive, I need them to add to positive 20 and add to positive 9. I put plus signs. And that gives me x plus 4 times x plus 5. Now, a way you can check this is if I FOIL it. You should get your original problem, which we do. Now, you obviously don't have to write out the list of factor pairs, but sometimes it's a nice visual to kind of think about what it is. All right, in example number 2, we have b squared minus 7b plus 10. Again, what I'm doing is I'm looking for 2 numbers that multiply to 10, but will add to negative 7. So I'm thinking of my factor pairs again, and we only have 2 this time. 1 and 10 cannot give me that combination, but 2 and 7. Now, before we use positive 4 and positive 5 to give us our positive 9. If I did positive 2 and positive 5 this time, I would get a positive 7. But what I really want is a negative 2 and negative 5. So those are going to be my pairs. And since this time b is the number being, or the variable being squared, I put a b here and here to represent the b squared. And I get negative 2 and negative 5. Again, you can check that by FOILing, and it should give us our original answer. If we look at example 3, we have t squared plus 3t minus 5. So again, I want multiples of negative 5, but which will add to 3. So if I think of my factor pairs, it's only 1 and 5. Now, 1 and 5 can give me different combinations. You can get positive 6, negative 6. You could get 4, negative 4. But you cannot get 3. And since there's no other combinations to give me multiple of 5, this is considered prime. It is not factorable, so it's considered, again, prime. Example number 4 is a little bit different because we see two different variables in here. We have p squared and q squared. Now, the only way that this differs than the other examples we've had is with that q squared. We'll put the p and the p here to represent the p squared, because basically I'm splitting into two parts. But this q over here is also a perfect square, so I'm going to put it in the back, and that will represent the kind of the splitting of the q squared. I'm going to do the same thing. I'm going to look for multiples that give me 6, that add to give me -5. So 1, 6, and 2 and 3. Now, you might look at this and say that both of them give us combinations of -5. The trick here is the negatives and the positives. This is a +6, meaning that both the terms have to be the same, because the only way that we can get -5 in this first one is if 1 is positive and 6 is negative. But +1 times -6 does not give us +6, so that is actually out. -2 and -3 give us -5, but it also gives me a +6 when I multiply, so I'm going to use those. And I put the -2 in front of the q and the -3 in front of the other one, and that is my factored. A few more examples. 3a cubed plus 12a squared minus 15a. This is a little bit different because we see that we have cube here as our exponent. And we have a coefficient of 3. If you remember what I said earlier in the video, the number one rule is to look for a GCF. And you'll notice that all three of these terms have a in them, so I can pull out an a, but they're all divisible by 3. So I can take out a 3a in each of these. I'm left with a squared plus 4a minus 5. From there, what I'm going to do is I'm going to try to factor this. I'm going to look for multiples of -5. So multiples of -5 that give me 4 would be 1 and 5, and the 5 would be positive and the 1 would be negative. So I would get a minus 1 and a plus 5. And I would keep the GCF on the outside. It is part of the factored terms. Our last example, 6x squared minus 19k plus 10, is a little bit different because you'll notice that there is not a GCF, and so we have to do a little bit different process. This is called factoring by grouping, and basically what you're going to do is you're going to take it from a 3-term polynomial to a 4-term polynomial. To do this, you multiply 6 times 10, which is 60. You think of the factor pairs that can give us 19, which are 4 and 15. And you take the 4 and the 15 and you use that to split the middle. So it becomes 6k squared minus 4k minus 15k plus 10. From there, what you're going to do is you're going to split the middle, and you'll look for a GCF out of both of them. A 2k here and a -5 here. And when I take the 2k out, I'm going to get 3k minus 2, and I'll get -5. See how that GCF comes there? And then I get 3k minus 2. Now, If my parentheses match, I regroup them, so I make one binomial from here, and then I take the 2k and the -5 and I regroup it there. Now, that's one kind of methodical way of doing factoring by grouping. Another way is just guess and test. You can think of the factors of 6, which are 1 and 5, and you know that has to go here and here. 1 and 6, or 2 and 3, and you try different combinations and you test that versus different combinations of 10, which are 1 and 10 and 5 and 2. We'll do one more example. 10x squared plus 17x plus 3. Again, what you can do is you can guess and test for this, thinking of factor pairs of 10 that can go in the first spot, and then factor pairs of 3 that go in the second, and then kind of guessing and testing using the FOIL. Or you can use the factoring by grouping by doing 10 times 3, which is 30, finding a factor pair that equals the middle number, and then making 4 terms. So 15x plus 2x plus 3, splitting it down the middle, taking out the GCFs. Now there isn't one here, but you take out a 1, and then you regroup it. 5x times 2x plus 3, put the 1 in front, then get 2x plus 3, and then putting them into the binomials. The 2x plus 3 goes into 1, and the 5x plus 1 goes into the other. And finally, my daughter Molly wants to say goodnight to everyone.
Good night.
See you later.
See you later.